Hello! So we're back here again, and in this video we're going to compare two different VELMA simulations. One was our baseline case for Watershed 1, and the other was the clear cut. So if you have not done these yet, then you're a little too far along in the video series here. You want to go check out, I believe it's the VELMA video 3, maybe 4, that focuses on creating a disturbance in VELMA. And so in the prior video, we ran this simulation here where I tagged on the end CC for clear cut. And so we clear cut the entire watershed, no matter what its age was or its position in the system. It's a very simple VELMA disturbance. There's no land management or ownership or anything like that, other than just everything is clear cut, no matter the age or anything. Just everything's clear cut. And so the reason I'm looking at these two screens here is that we want to compare our baseline, which was our initial run, to these results for the clear cut run. And we might even be able to see the clear cut occur. Yeah, because I was looking at this screen here in 82, 83, 84. So look at the biomass is very high, pretty mature trees. And then in the summer of 85, so these screenshots are always end of year in VELMA, but in the summer there was a clear cut event on day 190, J day 190, and so now our biomass is near zero. It's not all the way zero, it's a 99%, but that's what you should have had happen by this video. And so going to look at a few of the papers on this paper by Moore et al. Focuses in on the sap flow flux within individual trees. And looking over this whole paper for VELMA, I just want to focus in on this one table here as sort of like the punchline, I guess. Seeing here, if you read the description here, they notice that younger trees are all clustered together versus the older trees. And so the older trees here have a much lower sap flow flux, and versus these younger trees. And this because the younger trees here are having water move up through their system much quicker, as younger trees are using up more water compared to the more established older trees. This was also seen in this paper by Perry et al., where they compared, actually let me back up. So this is an individual tree level, but then, or even like small stand. Measurements are all per tree. Here in this one, this is focusing on the flow rate over catchment, and they were comparing old growth as the baseline versus clear cut. And so if you had an old growth stand and another stand, and there was no impact on flow due to the stand age, then you should see the data fluctuate around the zero. So this is a % difference treated minus control. And so if there's no change, you would see just the data kind of hovering around zero here. But there was a change, and so what we see here, because it's treated minus control, there was a very large increase in stream flow after the clear cut. Actually, this is the lower part B is a little bit easier to understand because it's relative to the treatment time. So clear cut happened, so now we're at time 0. We have an increase in stream flow, so treated minus control is a % difference goes up. But then after a while, you can see after about 10 to 20 years, the various stands, they start to, or the watersheds, as the stands recover, then ET starts to drop. And then this is the concern for salmon habitat and water availability, is because around 20 years, then this data showed that there is now a loss of stream flow, because relative to the old growth mature stand, again, if there was no difference, we should be at 0. But it actually, all the stands ended up dropping below 0 by whatever this blue standard, about 27. So 20 to 27 years at that point, then you have a loss of stream volume in the system. So that's what we did with our VELMA simulation. And so comparing these two results, what you want to do is you want to take the Excel file from before we had on the prior video with the results. We looked at the daily results CSV file here, and then I actually added in the observed flow data, and I had a separate tab. So that's the daily results here. So this was just showing how to plot the flow compared to the observed data. But I took this file, and then with these data over on the right with my clear-cut scenario, I launched this daily results file and grabbed the observed flow. Be sure to remove the first year. We always throw at least the first year of a simulation away as the water balance is working itself out. And so I plotted then 1981 on compared to, again, the data from prior video with these daily results. And what ends up happening is we get this. And so again here, these were my work from before, and then I added in the flow for the clear cut, removing all of the data from the year 1980 before I put it onto this sheet. And then I graphed the date versus my baseline runoff versus my clear cut, and you end up with a graph similar to this. Data-wise should be identical. I did rearrange this to put the clear cut behind, because then the yellow was popping up from before or behind the baseline run. So what we have going on here is from 1981 all the way up until the clear cut event in 85, summer of 85, the data were all the same. VELMA is a mechanistic model. There's no stochasticity going on. It's just simulating the way the watershed would function under VELMA's setup. And so everything is the same until we have the disturbance event. Once that occurs, now all of a sudden ET in the model changes dramatically. Massive loss of biomass. So there's the water is not escaping out through the stomata out into the atmosphere. And then therefore there's more water within the soil matrix and on the surface. So we have an increase in runoff, which is what we actually see, as we saw from the Perry and Jones paper. So we have an increase in runoff immediately going into the fall. Very large change here. And then actually let's see if we can even zoom in a little. That would make it easier. So a very large increase at first, but all the peak events as well. There's just much more water in the system. Now here we only ran this for about 5 years. So from the Perry and Jones work, we would expect that as we move out about 15, 20, 25 years, then these differences will shrink to the point where once the forest is reaching 30, 40, 50 years old, then we're actually going to have a loss of stream flow. So hopefully that shows how the mechanistic behavior within VELMA. Very similar things would happen under other scenarios. If you did climate change and you provided different climate drivers from, say, like a GCM model, then you could simulate if a system is warmer and wetter or drier, or change the seasonal pattern, maybe have wetter summers, earlier or later winters, just depends on the scenario you want to run. But you could also do other things like play with VELMA's soil matrix, and you could change things like the KS values, the soil depths, and that would be for like a scenario where maybe the landscape got modified for a very deliberate purpose. One that comes to mind is the watershed that is Xena Forest, managed by Willamette University. They had tiling when it was farmland, and there's been talk of the, well, one, the tiling is getting compressed and breaking down, but also maybe just have the tiling just directly removed to try to help improve the system, get back to a natural state. So you could simulate that in VELMA. If you knew where the tiles were, you could run the simulation and get a baseline, remove the tiles, and then reveal how the patterns of hydrology within the soil matrix would change. Also with forest structure, you could do other things besides clear cut. You could do riparian zones, and you could do forest thinning. The one thing that's a little limiting and would be possible but a little challenging is changing the forest structure. Currently in VELMA, at least as of this video, you can't change the type of forest structure it is. There's been talks of improving that so you could. So what I mean by that is you couldn't have a Doug fir forest and then switch it to an oak or alder or even farmland. It's just whatever the model initializes as is the current state. With some advanced techniques, you could run a simulation, stop, and then switch things out and then continue. That is possible, but that's beyond this level of the video series. So, the other thing, glad I was sort of rambling there for a second, just because it's also very helpful to always, with these hydrographs, change your y-axis to a log scale to really amplify those low flows and the difference. And so here we have our baseline again in blue. It's very low, and for a very short period of time, this would be great for the fish. There's a increased volume of water in the system in the summer, but as the Perry and Jones paper suggests, and other VELMA simulations that you could do here, you could run VELMA out longer. And if you did that, you would then see that around that 25-year mark, then there'll be a shift, and there'll actually be a loss, a pretty significant loss of summer low flow. So hopefully this was fun and very interesting. And go ahead and watch out for more VELMA videos that will start to get into niche details about the VELMA model and setup and execution and analysis. Thanks.